can we measure the oxidation number of any element, atom, in the molecule? We can make this one exactly by mathematical method. And don't forget some important rules. Group 1, positive 1. Group 2, positive 2. Group 3, positive 3. And we have some of constant, okay, or fixed sometimes. Like hydrogen, positive 1. And we can find hydrogen by negative 1. I'll give you an example for this. Oxygen, in general, negative 2. And don't forget, the all anions as SO4 sulfate, totally negative 2. Carbonate CO3, negative 2. I think I gave you all of this before, okay, for the all anions. Now, we'll start by simplest one. Sodium hydride. Measure the oxidation number of hydrogen in sodium hydride. Sodium hydride, NaH. At first, sodium here in group 1. So we have sodium as positive 1 and put hydrogen like H unknown. It is unknown. You can make this one as X, Y, Z, anything. But actually, you can use the symbol itself more easy. Now H, all of them for any molecule, the sum of charge equals 0. The sum of charge equals 0. So transfer this positive 1 mathematically.
Equation.
Now H equals negative 1. We said that before we have hydrogen here as positive 1, right? And sometimes we can find hydrogen as negative 1. Okay? And we said that before according to the difference in electronegativity. Remember? Difference in electronegativity. I'll give you another example. If I ask you about nitrogen in nitrogen molecule itself. Nitrogen molecule is N2, right? So we have 2N and all of them should be equal 0. The molecule here is 0. Divide by 2, divide by 2, so N equals 0. No lose, no gain. No difference in electronegativity between the two nitrogen atoms. N, covalent, right? Triple covalent. Another one. If I say here, by the same way for nitrogen as nitrogen in ammonia. All of you know that ammonia has symbol NH3. NH3. One by one. Nitrogen is unknown, only one. And we have hydrogen in general, positive 1. So it will be positive 1 multiplied by 3, right? All of them equals 0. So n plus 3 equals 0. Transfer n equals negative 3. Now we find here nitrogen as 0, and we have another nitrogen here as negative 3, right?
It depends or not.
Here depends on one thing, the difference in electronegativity for nitrogen and hydrogen. Hydrogen 2.1 but nitrogen 2.5.
لا يصير هنا كان صفر هنا صار
So
وش اللي غير؟ What changed
for what?
from 0
Yeah.
to negative 3? What's
No, we talk about here nitrogen itself, a nitrogen molecule, right? Nitrogen, a nitrogen molecule, that's mean 2n equals 0, right? Divide by 2, divide by 2, n equals 0. There's no lose, no gain. But here, electronegativity of nitrogen is more than electronegativity of hydrogen. Okay? As example, okay, nitrogen, oxygen, fluorine, 4, 3.5. This one is 3, not 2.5. Electronegativity of nitrogen is 3. But hydrogen, electronegativity 2.1. So, nitrogen has electronegativity more than hydrogen. So nitrogen can attract the electron to itself more than hydrogen. So nitrogen here has negative 3. Yes, sir?
Why did you add the 1 times 3?
No. Hydrogen here
Is 1.
is 1, positive 1, right? Not negative. So put positive 1. How many hydrogen you have? 3. So it will be 1 times 3. Positive 1 for hydrogen. 3, the number of hydrogen atoms. So total here is n as a known plus 3. Transfer 3, that means n equals negative 3. The oxidation number of nitrogen, negative 3. We have 0 and we have negative 3 only. No, we have more. Let us check another. Yeah, you can find it, okay, exactly in our circuit. Now, another one. If we put here as example nitric acid. The symbol of nitric acid, Mr. Yazid, is HNO3. Okay? Let us apply here. Hydrogen, positive 1, right? And nitrogen is unknown. Oxygen here is in general negative 2, right? That's mean negative 2 times 3. All of them equals 0, right? The molecule here as compound, the summation of a charge for compound equals 0. And we will find another one by positive and negative. So now we have n plus 1 minus 6 equals 0. It's okay? N plus 1 minus 6. So n negative 5 equals 0. Transfer this one. So n equals
Positive 5.
yes, positive 5. Don't say 5 only. Put the charge. Positive here, not plus. It is positive for the charge. In this case, we found what? Nitrogen as negative 3 and nitrogen here is positive. According to electronegativity of oxygen is more than electronegativity of nitrogen, right? So nitrogen should be positive while oxygen should be negative. Another one, if I give you a complex compound, look at this one. I put here for phosphorus. In what? In aluminum, hydrogen, look at this, phosphate, aluminum, hydrogen, phosphate. Al 2 HBO4 all 3. and here hydrogen phosphate. It is hydrogen phosphate, and we have dihydrogen phosphate and so on. So, one by one. Aluminum from group 3, right?
Yes.
Aluminum from group 3. Group 3 as positive 3, right? So, let us write it here. This one is 2 times positive 3 for aluminum, right? And we have hydrogen here. How many hydrogen? 3. So it will positive 1 times 3, right?
Yes.
Now phosphorus is unknown. Phosphorus is unknown. How many P we have? 3. Now that is plus 3P, unknown.
Negative 2.
Oxygen,
Negative 2.
-2. How many oxygen? 4. Total is 3.
7 يعني.
No, 12. So it will be -2 times 4 times 3, all of them equals 0. One by one. Now we can find here positive 6
4.
plus 3
3.
plus 3p minus 24 equals 0.
Factor?
Yeah, it's more easy now. Now 9 3p minus, if you have 24 by positive, by negative, and 9 by positive, 12p negative 15. Negative 15? So 12p negative 15 equals 0. Transfer it. So 3p equals positive 15. Divide by 3. Divide by 3. So p equals positive 5. Oxidation number of phosphorus here is positive 5. That is complex compound. But actually, it's more easy when I give you the symbol, right? I'll give you an example here for carbon. Mr. Ajlan, pay attention please. I give you here practice. I need carbon, oxidation number of carbon, and acetic acid. And I give you the acetic acid is CH3COOH. One by one. Yes, Mr. Aziz?
C.
Yeah.
Will H negative 2.
No, sir. Check here. Hydrogen is positive 1, right?
Yeah.
Times
3.
3, it will be 3, it's okay?
C.
Yeah. Plus
Unknown.
C, the unknown.
Negative 2.
Negative 2.
Negative 2.
Negative 2.
Positive 1.
Positive 1. All of them equals
0.
Now, how many carbon you have? 2C, right?
Yes.
Okay. 3 and 1, that's mean 4. Negative 2, negative 2, negative 4. All of them equals
0.
So cancel, cancel. It's okay. Now 2C equals 0, so HC equals 0. Oxidation number here is 0. So we can measure the oxidation number by knowing the other oxidation numbers, right? The last one for carbon 2. I put here carbon for ethanol. Ethanol CH3CH2OH. Now carbon is unknown, plus 3 plus carbon plus 2 minus 2 plus 1 equals 0, right? Now we can cancel more easy way. We have C and C, that's mean 2C plus 4 equals, transfer this, 2C equal negative 4, divide, so each carbon equal negative 2. So, several elements have different or many oxidation number. That is depends upon the difference in electrolytic.
أستاذ
Yes, sir.
إيثانيل
Ethanol?
What's
No, that's compound. We'll take this one, inshallah.
ما له دخل يعني.
No, not the Yeah, if you want this one, sir. Okay, thank you, mister. Thank you.